Okay, so good morning, children. We'll be starting with the class today. So, I think it would be better if I summarize what we have discussed in the previous class. So, we have started with the introducing the environmental engineering subject to you. So, in civil engineering, environmental engineering is actually a very important subject. It has imparting your 11 to 12, 9 to 11% of your marks in your civil engineering paper. So you have to take it very seriously. Why? Because it is not like any other subject. It is very easy to study, very like things which are very much known to you. You see it every day in front of you. All those things only you have to study. Nothing very big to study or very complicated to study. Easy things only. And numericals coming up will be very easy only. We'll be discussing upon it. We'll be practicing as much as questions as possible. Means we'll be practicing them all. Will be here to you. Okay, so study it very seriously. Why? Because this subject is gonna be the one that is making you score very good marks in your exam. Okay, so let us see what is happening in that. Okay, and the first thing which we discussed yesterday was introduction to environmental engineering. We said that there are mainly two topics that is involved in environmental engineering. Mainly, if we look into the syllabus of environmental engineering, we'll be able to classify the entire syllabus into two main things. Okay, and you people are able to hear me. Aditya, Sanita, are you able to hear me? Am I audible to you?
Yes, ma'am.
Fine then. Okay. So if my sound is breaking or something new, just inform me. Okay. I don't know if it is okay for you. And is my screen visible to you people? Okay, fine. So we'll be starting, and as we told yesterday, we'll be having two classification in the entire syllabus. One will be dealing with raw water, and the other will be dealing with what? Wastewater. So you know what is raw? You just come here. You can sit, because the screen is not available. So we'll be having raw water as well as we'll be having wastewater. Should I increase it like this? It's okay for you. So raw water will be there and wastewater will be there. And raw water, like we have a general conversion between this to this, right? Actually, what we people do, we people will take up water from different sources, that is raw water from different sources. We'll take it up and we'll convert it into wastewater, right? And after the use, actually for centuries from the industrial development, what we people did is we took water from the raw water sources, we converted it into wastewater. Again, we took water from raw water sources, converting it into wastewater. Now, when environmental enthusiasts came in, when we people started to be concerned about the environment, we also thought of the methods to convert the wastewater back into raw water so that we can conserve water. Got it? So, this is the entire process which we are going to discuss mainly there in environmental engineering. Got it? Let me share the presentation just a minute. This is the thing which we discussed yesterday. Actually, we have to convert this raw water to wastewater, and then what we people do is we convert the wastewater back into raw water. This is the entire process we have to discuss in this subject. And what are coming under raw water and what are coming under wastewater? Under raw water, we have water demand, population forecasting, which are one of the most important topics from where we get the numerical problems. Water demand, we have to calculate water demand after this much of years, after 30 years, or after 50 years, or after 100 years. We'll be asked to calculate how much is the water demand. So, what is actually water demand? It is the water that is required for a person in a day for his domestic use as well as drinking purpose and all. For all satisfying all the needs of that person, how much water is required for a person in a day? That is called water demand. We call it as per capita demand. Okay, so we have to find what is the water demand of a person or for an area. having this much population in this year. Okay, so that will be asked under water demand, and such numericals will also come under this. And after that, we'll be having population forecasting. So we have to forecast the population that is going to come up after 30 years or 50 years or something. The trend will be given to you. And like 2010, it was like this. 2011, it was like this. 2012, it was like this. You have to calculate the population after 70 years. Got it. So you have got methods to calculate population forecasting. You'll be studying those formulas. You just have to apply values into the formula, comprehend the question correctly, apply the values. You'll be getting the answers very easily. So these two topics are, yes, they are important, but not the most important topics. Still, there will be at least one question regarding either water demand or population forecasting problem will be there. Okay. Now coming to the next topic, it is sources of water. This is also important by because we have got different sources of water, like we'll be getting surface water, subsurface water, right? And we'll be getting water from the atmosphere also, right? So all those sources, they are important. Yes, we have to study about them. It is moderately important actually. But that is why I've given green color to them. Now coming to the most important topic that comes under raw water, that is the water quality parameter, and then it comes the treatment of water. Now what is water quality parameter? So those are the parameters that indicates how much quality does our water have. Is it bad quality water or good quality water? Is it suitable for drinking? Has the quality been okay for drinking purpose? Or is it for domestic purpose? Or it has the quality to meet industrial needs and all? We have to analyze based upon these parameters. Okay, so such parameters are called as water quality parameters. We have got several different parameters to discuss. For each parameter, we'll be having characteristics, we'll be having limits of the values, we'll be having measurement techniques. All these things we have to study, and that becomes the most important topic in our syllabus. Got it? Now coming to the second most important topic, that is treatment of water. Whenever you get water from the river, you will you directly take the water from the river and drink it? No, we can't do that, right? We suspect some sort of pollution somewhere. Sometimes the water coming from the river may be having some mud or dust in it. Dirt particles will be there. Sometimes it may be polluted by some bacteria or microbial organisms or something. Sometimes in the course of the river, there may be an industry putting their effluents into the river. Then this water may have some chemicals in it. So all these things we have to be concerned about. So whichever like raw source which we get from the nature, we get the water from it, we treat it as it is, right? Even though we take water from the purest well, we will have the tendency to boil it, right? After boiling, we'll feel that okay, it is safe. Right? Because if it's having some microbes, it will be dead, right? So we have to have some treatments on the raw water which we draw from the natural sources. So that is also important. So what are the treatment techniques for each kind of quality of water? Okay, now to adapt the source of water or to select the water demand or to select the population forecasting or do any other resources or practice any other practice there in the environmental engineering, we initially require the information on water quality parameter. If we have the idea of water quality parameter, then only we'll be able to do all these other courses. Got it? And the last one, this is distribution and conveyance system, and this is the least important topic that comes under this. This means that this doesn't mean that you won't get any question from here. You will get, but it is the least important compared to the rest of the topics. Okay, so distribution and conveyance system comes after the treatment of water from the river. If we look at the water supply from the government, okay, the government is providing us pipeline water supply, right? And what these people do, they'll take up water from natural sources. They'll have some treatment to the water like chlorination or something. Then they'll be providing that particular water to us through different pipelines, right? So those pipelines comes under the distribution and conveyance. Sometimes it will be big vehicles carrying water will be coming to remote areas and all. Na? So for those areas where this particular pipelines cannot be laid, sometimes it will be a very hilly area. We cannot pump water onto that area using pipelines or pumps. Then what the people do? The people will employ several big vehicles or carry vehicles to take water from this available place to the remote areas. So those people will be waiting with buckets to take water from this vehicle, and they'll be coming in queue and they'll be taking the water, right? We have seen it several times, right? So all those things also comes under the distribution and conveyance. So all those things, everything that coming under the raw water system, it can be calculated or determined only based on the water quality parameter. So that is the reason why we will be studying about the water quality parameters first. Got it? Any doubt in all these things which I have told you? Any doubt, children? Okay, so if you have any doubt means you have to ask me. Okay, I don't know if you have any doubt means you should ask me. Okay. Okay, now let us continue. So this is the general idea about raw water. So we'll be, first of all, we'll be discussing about water quality parameters and then only we'll be moving on to the rest of the topic. Okay. Now coming to the second thing, wastewater. Again, what is wastewater? Wastewater is the water which comes after our use, right? We take raw water from the resources, we'll use it and we'll convert it into wastewater. If we use it in the kitchen to wash our plates, raw water is getting converted into wastewater. If we use this coming water into our bathrooms or toilets, it is again getting converted into wastewater. If we use the raw water for any purpose, it is getting converted into wastewater. So the first thing we have to study is wastewater characteristics. So what are the characteristics of a wastewater? So different wastewater coming from different sources will have different characters, right? A water that comes from an industry, even industries can have different kinds of wastewater. If it is a dye industry means we are giving colors, right? So colors are being mixed with our water. So the wastewater coming out of the dye industry will have a peculiar characteristic of dye, right? Now the wastewater coming out of an acid industry, it will be having as acid content in it, right? So it will be different from what is coming out of a dye factory. And that will be different from what is coming out of some other food industry or something, right? So for each industry, the wastewater coming out will have different characters. And this industrial character will be entirely different from what is coming out of a household water, right? So if I'm having a home, like a residential area, I'm collecting wastewater from the residential area and I'm bringing an outlet, and that particular water coming out of the residential area will be entirely different from that of the industrial area. And this will be different from that of some other areas, right? So depending upon the application of water, the wastewater characteristic will also change. Got it? So we have to study what are the different possible characteristics of a wastewater, and then we'll be studying about the sewage system. How can we collect this wastewater? So sewage means you people know what is sewage, right? Sewage is the water that comes out as waste, right? So those sewage, we have to collect it using a sewage system. We'll be having pipelines to collect it. We'll be conveying it together to a sewage treatment plant. We call it as STP. Okay, we call it as sewage treatment plant. So we'll be bringing the entire system to a sewage treatment plant and we'll be treating it according to the wastewater characteristics. So according to the wastewater characteristics only, we'll be designing the sewage system as well as the treatment. So if the wastewater is having a lot of acid content in it and I am giving a treatment for organic, it is not required, right? Organic is entirely different from that of acid. So I have to first of all analyze what is the character of the wastewater. Then only I have to decide which treatment technique should I adopt in my STP. Got it? So that is another important thing. And then we have disposal of sewage effluent. Okay. So after the treatment in the treatment plant, we'll be having effluents from the sewage, right? So this effluent we have to dispose it very safely. If it is solid waste, we'll be disposing in one method. If it is liquid, we have to dispose in another method. If it is gas, we have to dispose it in a different method. Right. Now coming to solid waste. If it is a solid waste, we have to have solid waste management, right? So how can we manage solid waste? We know that the main and major problem regarding solid waste is that solid waste has volume. It has got volume, right? What is volume? Volume is the space occupied by it, right? You just imagine you have bought a cake from a shop. Cake. And what those people do, they'll be giving a big box, right? A big box will be there to keeping the cake. You eat the cake, the box inside, inside the box you'll be having only air. But still the box is having a volume, right? So it is big in size. Even if we try to fold it or do something, means it is bigger in size itself, right? So that particular waste, solid waste will occupy that much of volume. So what we people have to do in order to manage this solid waste? The only method, like we'll be having several different methods. If in this case, we have to do volume reduction. What is it? Volume reduction or size reduction we have to do. So how can we do volume reduction or how can we do size reduction? And what after that? Even you do size reduction or volume reduction, still the waste is there, right? So what can you do with the waste, solid waste? How can you manage it or how can you dispose it? You have to study about it. Have you heard of landfills? You have heard of it, right? Landfills are the place where we dump solid waste, right? So what we do in landfill? A landfill we'll be having different kinds of landfill. The first thing we'll be do, like mostly in the landfills which we see in our area, what is happening is they'll be acquiring an area, then they'll be having a pit. Okay, in the pit they'll be dumping one layer of solid waste that is collected from the residential area or industrial area in which it is intended. Okay, and then they'll be putting a layer of soil over it. Okay, a layer of soil over it, and then they'll be giving good amount of compaction. Got it. Now after this, after a few days, we'll be collecting the next set of waste, and that will be dumped over this. Got it. And then we'll again put soil particles over it. A layer of soil will be put over it. And due to the self-weight of the soil, this gets compressed. Got it. So like that, we'll be dumping more and more layers over this. And these layers accumulate. And as the layers accumulate, the weight increases. And due to the self-weight, this particular region gets compressed and compressed. Got it. So we'll be able to maintain the height. Even though it is increasing, it is not that much increasing by because upward the weight accumulates, the more will be the compression that is happening to the lower layers. Got it. So as such, we'll be able to maintain the height. And one of the most important thing we should understand is when we have this weight over this, now when compression occurs, there may be leachage happening out of this, right? Leachage may go out. See, if you have some battery or some chemical waste inside a solid, you have dumped it here. Okay. Now, if you have this self-weight, what happens is this chemicals will have a tendency to leach through the soil particles, right? Because soil particles are having pore spaces in between them, right? So what happens is these particles or this particular leachate will try to leach through the soil particles, and they may have a tendency to reach the groundwater over there. Got it. So this may pollute the groundwater. So what will we do? What we do to ensure that the leachate will not reach the groundwater is that before dumping the first waste layer, we will be creating a seal. What is it? We'll be creating a seal. A seal will be an impermeable layer. Okay, an impermeable layer will be created so that none of the leachate will leach through it and reach the soil. Got it? We call it as liner. What is it? Liner. So liners will be provided so that there will be no leachate occurring, no leaching occurring from the base towards the ground. Got it? So in such a way, we'll be able to conserve the soil particles and groundwater over that area. So we should give proper liner in a landfill. And after that, we'll be dumping waste soil, waste soil, waste soil. Layers will be formed. And due to self-weight, these layers gets compressed, and this compression will control the height of the landfill. And the landfill will have almost a life of 30 years or something. And by the end of 30 years, the lifetime will be over, and we have to stop dumping waste over the landfill, and then we have to go in search of a newer area. And now what we do with this ancient landfills, like once the landfill is finished with its use, what we people do is we'll be growing grasses over it. We'll be putting layers of soil over it. We'll be putting good amount of manure, and we'll be growing grasses over it. Then we can use it as playgrounds. We can use it as parks, etc. We'll be able to we won't be able to do much constructions over it, right? Because if we have to do construction means we have to dig and make the foundation, right? That is not possible in this case, but because we are having waste beneath the soil. Now what we do, we'll convert it into useful places like parks or gardens or something. We'll be making it, and then we'll be utilizing the space aesthetically. Got it? So this is the general idea of disposal of solid waste management. Now, after that, there comes another important topic, that is air pollution. Now, what is air pollution? How is air pollution happening? What are the sources of air pollution? What are the sources of air pollutants? Now, what are the impacts of air pollution? Now, how can we convert air pollution? These are the things we have to study under air pollution topic. Got it? So, this is the general idea about the syllabus of environmental engineering. Did you get it? Is it okay, children? Is it okay? Okay. So then we'll be moving on into the syllabus. So what I'm going to do is I'll be starting from here. Okay, water demand and population forecasting I'll be discussing later. I'll be starting from here. I'll be introducing you the sources of water. Then we'll be moving on to water quality parameters. Got it? So sources of water. We are having, when we analyze the Earth's surface, we are having generally two different sources of water. One is surface source and the other one is subsurface source. Now, what is surface source? Any water body that is present on the surface of Earth can be calculated and classified as surface source. Now, what is subsurface source? It is present below the surface of Earth. Okay, so if this is the surface of Earth, any water body that is present above the surface will be considered as surface source, and any water body that is present beneath the surface of water, surface of Earth, can be written as subsurface source. Got it? So groundwater and all comes under subsurface sources, while rivers, lakes and all comes under surface sources. Got it? Now what we people usually do is we will be drawing up water from these two sources, right? We'll be either taking water from surface source like rivers, lakes or something, or even from the oceans or seas, and then we'll be taking water from the subsurface sources like wells. Then we'll be having tube wells, etc. Will be used. Got it? And after we'll be also having sources like rain, snow, hail, etc. We'll be discussing about them later. Now we'll be discussing about what is there on the Earth's surface. Got it? Now we are moving on. Okay. Now I am having a reservoir. Let it be a lake or a river or something, or even a dam. And now I'm taking water from the reservoir. Okay. Now I'll be pumping the water to a water treatment plant. What is it? Water treatment plant. Now, what is happening inside the water treatment plant? Treatment is happening inside water treatment plant. What kind of treatment we are doing? We are doing the treatment based upon the characteristics of the water that is coming from the reservoir. If the water coming from the reservoir is having high amount of biological matter, I have to do the treatment according to that. Now, if the water coming from here is having acid content, I have to do the treatment according to that. If it is alkaline, I have to do the treatment according to that. If it is having some excess of metals like iron or something like heavy metals or something, then we have to do the treatment according to that. Got it? So after the treatment, what do people do? We will be getting the water from the treatment plant and we will be distributing it to different like resources where the water is getting used. Okay. This is the general idea of water distribution in a city or in a village area, how the government generally does it. Got it? Now, how much water should be drawn from this? How the pump character should be? Should the pump be before or after the water treatment plant? What kind of treatment should happen inside the treatment plant? How much water should be distributed? Everything has to be determined by the quality of the water taken. So this is very, very important. Okay, so now we'll be moving on to the different quality of water. Got it? Now, what is quality of water? Before that, you have to know what is the raw water. Okay, so you people know what is raw water, right? Yes, we'll be having a, like, I'm just having a quick review of yesterday's class so that someone newly joined will get to it, right? So then we'll be moving on with the newer topic today also. And I think for the GATE, ABS and civil, you'll be having the classes in weekends, isn't it? The classes are scheduled on weekends only, right? I was told that your classes will be scheduled like this one. The subject classes will be scheduled on the weekend and aptitude and maths will be going on in the weekdays. I have to confirm it and then I'll be letting you know. Okay. Oh. Now, coming to the quality of water. We'll be having a raw water, right? What is raw water? You people know. Water that has not been subjected to any artificial treatment. That is the water directly drawn from any of the sources like rivers, lakes or something can be called as a raw water. Now, what are the parameters to determine the quality of raw water taken? You'll be having three different kinds of parameters. What are they? You'll be having physical parameters, chemical parameters, and biological parameters. So, physical parameters means those parameters that can be observed physically by our senses. Like we can see it, we can taste it, we can smell it, we can see what is inside it. I mean, we can touch it and feel what is the temperature and all. Then we can call it as the physical parameters. Now, what about chemical parameters? Those parameters that input chemical reaction, which we cannot see with our naked eye, but there are chemically happening inside, means they can be called as chemical water quality parameters. And the last one coming up will be biological water quality parameter, which means that it is having some biological things in it. Biological means living things in it. Okay, those living things will be polluting the water, then we can call it as biologically polluted. So that parameter comes under biological water quality parameter. Okay, now coming to physical water quality parameters, what are the important physical quality parameters? So here it is a definition. Parameters that indicate the physical properties of water can be called as physical water quality parameters. Those parameters can be sensed physically. Okay, so what are the examples given over there? Color will be there, taste and odor will be there, turbidity will be there, suspended solids will be there, temperature will be there. Got it? Now color. You people know water is actually what? Colorless. Water is colorless. So if you see some characteristic color in water, if I am giving you a pale yellow color water, will you drink it? No. Why? Because it is having some color. We know that actual water will not have any color, right? It is colorless. So color becomes an important physical parameter. Okay. Now the second one is taste and odor. Taste, you can do it using your tongue. If you like taste some water, if it is having some characteristic taste, we can say that this is not pure water. We don't want to drink it. Got it? So taste, actually water, pure water is what it is tasteless, right? Pure waterless, colorless, odorless, and tasteless. Got it? So if it has some color, or if it has some taste, or if it has some odor, means it is not pure water, it is polluted water. So it may be polluted in a good sense or in a bad sense. Sometimes if you put some sugar in the water, means it is going to taste different, right? But still it is good. But still we can say that it is not true water, it is a polluted water. Now coming to the next thing, that is turbidity. So what is turbidity? We'll be losing the transparency of water, right? Generally water is transparent, so if you look into a water and we are not able to see the other side, the water is not transparent, means we can call it as turbid water. So if I give you some turbid water to drink, you look into it, you can't see the other side, will you drink it? No, right? Why? Because turbid water, it may be different, it may be due to different reasons. Okay, so we will not trust the water to drink it, right? So turbidity is yet another physical parameter that we give a good concern, right? And the next parameter is suspended solids. So what are suspended solids? Suspended solids are those solid matter that is suspended in the water, right? We'll be able to pick them up. We'll be able to see it, right? So then we'll be calling it as suspended solids. Now lastly about the temperature. Water is actually having a temperature range, okay, and water temperature range should be that only. If it varies lower or upper, it is problematic. Why? Because if the temperature goes very much up, what happens? The aquatic life in the river or lake will get affected, right? And if the temperature goes below a fixed value also, it is going to be difficult for them to survive. So temperature is yet another important physical quantity. Got it? Any doubts regarding the physical water quality parameters? Any doubts? Any problem, children? Okay. Now we'll be moving on seriously into each of the physical water quality parameters. Now, what is the first physical quality parameter which we are going to discuss? It is suspended solids. So, what is suspended solids? Any solid matter that is suspended in the water that can be visible to our eyes can be called as suspended solids. So, before studying about suspended solids, we need to study this concept. Okay, in a water there will be suspended solids along with another quality that is called as dissolved solids. So sometimes if you put water, salt into water, you dissolve it very well. Will you be able to identify that salt is present inside the water without tasting it? No. Why? Because when we physically observe it, we cannot see the dissolved salt in it. So since it is NaCl, it is having taste. Sometimes some salt it doesn't even have some taste. So even if we look at it, if we drink it, we smell it, we won't be able to identify that there is some dissolved solids in it. So that is very important. So dissolved solid forms a chemical quantity. Okay, it is a chemical parameter to discuss about. Okay, and suspended solid is a physical parameter. So if we go for adding the two, that is suspended solids and dissolved solids, you will be getting the quality called as total solids. So total solids is nothing but suspended solids plus dissolved solids. Got it? So Ts will be equal to Ss plus Ts. Clear, na? So this is the general introduction about suspended solids. Now, what are the problems regarding suspended solids? So why are we getting this much concerned about suspended solids? So if you have a glass of water that is having some solid suspended and floating in it, will you drink it? No. That is a major and most important after effect of having suspended solids in water. Even if it is not harming you, you won't drink it, right? Will you be able to drink it? No, I personally won't be able to drink it. Why? Because there are suspended solids in it. I know it may be harmful or may not be, but I am not ready to drink it, right? So that is one of the most important aspect of suspended solids. We won't drink it. We see it means we won't drink it, or even not drinking it, we won't use it also, right? So that is very important. Okay, now coming to what are the problems with suspended solids other than the aesthetic reason? We call it as the aesthetic reason, right? Why? Because if we see to it, we don't like it. Then we call it as aesthetic problem. We are having aesthetic problem, so I am not ready to drink that particular substance, right? Now, what about if you are going to like supply the water having suspended solids through a pipeline? What will happen after a few days? Few days of pumping. Yes. Few days if you pump this water having suspended solids through a pipeline, what will happen? The pipeline will get clogged or blocked, right? Why? Because the suspended solids may accumulate somewhere and it may form a bigger obstruction. And this causes the incrustation inside the pipeline. What is it? Incrustation. What is incrustation? Incrustation means blocking of the pipeline, right? It means blocking of the pipeline. Got it. So if you have suspended solids for more than like this much days there in a pipeline carrying water, what will happen? There is a chance of clogging of this suspended solids there in the water pipeline, causing the incrustation of the pipeline. So this can block the supply of water smoothly. Got it? So this is another aspect of what is it? Suspended solids. So the first one was psychological aspect, which means we won't be able to drink the water if it is having some suspended solids. The second one is incrustation of the pipeline, right? So we won't be able to control the incrustation. We have to clean it again and again, right? So that will be another important aspect of suspended solids. Now the next one coming up is this particular thing you have to be very careful. I haven't discussed this in the last class. Okay, I'm going to discuss it freshly. So this particular thing you will have to have it in a it is something out of the box. So you have to think it in that sense. Okay. So I'm having some microbes in my water. Okay. I'm having a water sample. I'm having suspended solids in them. Yes, suspended solids are there. And I'm also having some microbes over there. Okay. Now what happens to these microbes if they have suspended solids in it? What these microbes do is they'll be using the suspended solids as a shield. What they use it as? They'll be using it as a shield. So what they do is just imagine myself to be a microbe. What I do is I'll go and I'll be hiding behind one of the directions of one of the sides of the what particles, suspended particles. Now, when there is a person is standing there, so he is going to treat this wastewater, okay, or the water coming. And this person has already analyzed the presence of microbes, that is me, inside the water. So what will this person intend? This person will intend to do some disinfection process so that it can kill me, right? So what these people do is they'll be applying chlorine. Why? Because chlorination is one of the most widely accepted form of disinfection, right? So what these people do is they'll be adding some chlorine. They'll be adding some chlorine into this. So what I have already done, I have went and sticked on to one of the side of the suspended solid. Now what happens is when chlorine is down, this suspended solid will attract chlorine to the other side. Okay, so the suspended solid will give binding spaces. What is it? Binding spaces from where this chlorine particles can come and bind. So what happens? How much the suspended solids are there, that much will be the binding with chlorine particle. So those binded chlorine will not be able to kill this bacteria over here or this microbe over here. Got it? So what happens is how many chlorine you put, that much chlorine will get clogged with or attracted towards the suspended solids. So what these people have to do, the person standing here has to apply more and more chlorine. Got it? So this person has to apply more and more chlorine. That is to purify a very little amount of water, so very large amount of chlorine will be required, which means the efficiency of chlorination. What is it? Efficiency of chlorination will be reduced. Got it? So efficiency of chlorination. When is efficiency of chlorination more? When I put a very little amount of chlorine and I'm getting very good disinfection, then I call that this chlorination is very efficient. But here what is happening? Since the suspended solid is providing an active binding area for the chlorine particle, what this chlorine particle will do? They will be coming and sticking onto the side of the suspended solids. Got it? And I on the other hand is hiding behind the suspended solids. So this particular chlorine will not be able to kill this bacteria or this microbe. Now this will reduce, this will like initiate a necessity to add more and more chlorine into the given water sample. So less water, more chlorine, which means the efficiency of chlorination will get reduced. Did you get it? Is it okay for you people? Okay, now that is another important thing, that is it provides active, suspended solids provides an active absorption side for the chemical that is given into it, okay, for the purification purpose. And another important aspect is if your suspended solid is organic in nature, okay, if your suspended solid is organic in nature, what will happen? If your waste or the water taken has organic matter in it, so or the suspended solids taken is organic in it, so what will happen? Yes, organic matter is getting digested by microorganisms, right? So organic matter is actually the 4 to 4 microorganisms. So wherever they get food, they'll come to there, right? So if I have organic matter inside the suspended solids present in the water, what the microbe do is they'll be coming for food. Since they are getting a large amount of food here, what the people will do? They colonize over there, they'll be having spread, like binary division will happen, and they'll be multiplying into several saplings. So what happened? This pure quantity of water or a small amount of polluted water will get converted into a largely polluted water with a lot of microbes inside. Right? So if you have organic matter there in the suspended solids, it will result in the excessive growth of microorganisms inside the water. Sometimes the microorganisms growing inside may be pathogenic also, that is they may cause diseases. So if they are pathogenic means what will be the case? We have to remove it, otherwise the entire people consuming this water will have pollution causing organisms. Disease. Got it? Clear now? Is it clear for you people? Okay, so that is the general idea regarding suspended solids. So I'll be giving you 10 minutes. You can like just summarize whatever I have said now. You can just summarize and write it in your own words. You have to scribble it, okay? Write it in your own words so that it is understandable for you people. Okay, so you should like, okay, what are suspended solids? What are the different categories of suspended solids? We'll be discussing about sources of suspended solids after this. Okay, what are the different sources of suspended solids after this? So we have got 4 different problems regarding suspended solids, right? 4 different troubles regarding suspended solids. What are they? The first one was it will be providing psychological effects, right? We won't be able to have it aesthetically, so we won't be using it. Okay, and the next one was incrustation. What is incrustation? If you have suspended solids, means it will cause clogging of the pipe, right? Suspended solids may come and deposit over the sides of the wall, causing clogging. That's called incrustation of the pipe. Now, what is the fourth one? It is about the microbes, right? Microbes will hide behind the suspended solid particles. The suspended solid will provide a good amount of binding space, active binding space for the chlorine particles to bind. So they will be coming and binding, which increases the requirement of chlorine for disinfection. So more amount of chlorine requires to be added, which decreases the efficiency of chlorination. Got it? So that is the third point. Now what about the fourth point? Organic matter is present means what will happen? The bacteria will come to feed upon the organic matter, which will increase the chance of disease-causing microorganisms or pathogens growing inside the water. Got it? So this cannot be controlled. This may go beyond the control. So this can cause several waterborne diseases. Got it? So all these things you can just summarize using whatever representations you require. You can summarize. I'll be giving you short notes. Yes, I'll be giving you maximum hard copy or soft copy. I'll be giving it to you by the end of this week or something. Okay, I'll be giving whatever we are taught until this. I'll be giving you the notes. Okay. No problem, right? So you can just take 5 minutes to just summarize and write what we have discussed now, so that I can see whether you are able to memorize the things which I have told you or not. Okay, so you can take 5 minutes and memorize. Okay. So hope you people are okay with all these things which we have discussed, right? So these particular things, that is the problems regarding suspended solids and all, you should be knowing it in like that, okay? That you have to be careful of. Now, after this, we'll be having okay. After this, we'll be discussing about what are the different sources of suspended solids. Okay, so how are suspended solids coming into water, or what are the different sources of suspended solids? We are going to discuss. We can give the heading as sources of suspended solids. So suspended solids may be anything that will not dissolve in water, right? It should not dissolve in water. It should be remaining as suspended air and water solids, right? So that is what we call it as suspended solids. Now, what are the different types of suspended solids or sources of suspended solids which we can have? Okay, and the first one will be inorganic solids. You can write it, inorganic solid or inorganic matter. Now, generally, inorganic matter means those which are not having any organic conditions in it, right? Just like if we speak about sand, sand is not having any organic matter in it, right? Then we can have silt, right? Sand is there, silt is there. Then we can talk about clay. So sand, silt, clay, etc. comes under inorganic matter that can be acting as a suspended solids in water. Got it? So this is important, one of the sources. Now the second source will be, if it is inorganic, the next should be what? Organic one, right? So we can write it as organic matter. Now what do you mean by organic matter? Organic content means it should have carbon content in it, right? So whichever material that has carbon content in it can be called as organic matter. Okay, so it should have carbon content in it. Got it? So it has carbon content. Now, what are the examples of organic matter? You may have plants, right? Plants may be there. Then any other algae may be there. Then have you heard of planktons? Planktons you have heard of, right? Phytoplanktons and all. Have you heard of it? Plankton is small plants, small organisms that will not have differentiated like plant parts. So they'll be just like an algae, but it will be smaller in size. So we call it as plankton. If it is plant means we call it as phytoplankton. Okay. So generally planktons will be there, and then we may have algae. Yes. Then we may have fibers. So what are fibers? Fine fiber-like materials like cotton will be there, clothes will be there. Then if you look at the coconut fiber is there, na? So all those things comes under the category of fibers. So fibers may be there inside water. That may also call the like suspended solids. Got it? So that is the second case, and the next and third source and the final source will be immiscible liquids. What is miscible and immiscible liquid?
Miscible is not, it can dissolve.
Dissolve. Miscible means both the liquids will get dissolved. Just like you have some salt water and some like some other sugar water or something. You just go for mixing them. What will happen? They'll mix each other perfectly. They'll be dissolving, right? But immiscible liquids are like oil and water or grease and water. What will happen if I drop some oil in water? It will suspend over water, right? It will not mix at all. Even if you try for the best, it won't mix. If you have grease on water, will it mix? No, it will just like form a layer over water and it will be there only, right? Based on the density gradient, it will be differentiated. Okay, so immiscible liquids such as oil and grease can be considered as the next set of what it is. Sources of suspended solids. Okay, so these are the 3 different sources. You can write the sources and examples. Inorganic matter like sand, silt, clay, etc. Organic matter, which means the matter that is having carbon content in it, like plants, algae, planktons, fibers, etc. Now, immiscible liquids such as oil and grease can also form suspended solids. Got it? Clear, no? Now, one of the most important point which you should remember is suspended solids will be found in surface water only. It cannot be found in groundwater. Why? Present in surface water only. Actually, yes, this particular water, groundwater, is present beneath the earth. Na? How is it formed actually? If you have a soil layer over here, we'll be having rain over this. This rain water will seep down through the soil layers and form the groundwater, right? And while the seepage occurs, our soil particles are that much compact that it will not allow suspended particles to penetrate through it and reach the groundwater. It will be acting as a filter. It will be acting as a filter. And this filter will prevent the formation of suspended solids there in the groundwater. But in the surface water, there will be immense amount of suspended solids, but it will not be there prominently in the groundwater. Got it? So you have to note that point there. Suspended solid is actually a pollution parameter that happens in the surface water and not there in the ground. Got it? Now, how is suspended solids measured? Measurement of suspended solids. I'll be explaining the process in detail later. Now you just have to note down the name of the process, that is gravimetric technique. Gravimetric technique. The name itself suggests that it is based upon gravity only. We are going to separate it. Okay, so that particular method, there are a lot of methods based on gravimetric technique. I'll be explaining it to you, which all are important and necessary for you means I'll be explaining it to you. Generally, it is called as gravimetric method, okay, or gravimetric technique. You can note it out. The measurement of suspended solids is done by gravimetric technique. And now, what is the limit of suspended solids? Based upon EPA. EPA is Environmental Protection Agency. So, according to EPA, what is the limit of suspended solids? That is what we are going to tell now. And the limit as per EPA, it is suspended solids should not be greater than 30 mg per liter. According to EPA, there is not EPA is not the only one that is suggesting the standards. We are discussing about EPA now. We'll be having the standards discussed. As I told yesterday, I'll be giving you a table-like format in which we'll be having all the like parameters to be discussed, how it is measured, what is the limit according to each of them. Okay, so that I'll be providing you. Now you just have an overview of it. Okay, so suspended solid, the limit according to EPA, it is suspended solid should not be greater than 30 mg per liter. Got it? Any doubt?
What's EPA?
Environmental Protection Agency. Actually, it is US EPA. It is the Environmental Protection Agency in US, United States. So what we do is we generally depend upon their principles for protection. Why? Because they have formulated it with very, like, they are actually a developed country. Now they are having a lot of industrial influence, but still they are using the standards, means this should be good. That is why we are following it. We have our own standards also. We have IS standards also, Indian standards also. We'll be studying about each of the important standards when we study about the table. Okay. That is the limit of suspended solids over it. So that is over there. And suspended solids can be classified into two actually. Okay, suspended solids can be classified into two. And the first classification in detail we'll be studying later. Now you just note down the names. Suspended solids can be classified into filterable solids and non-filterable solids. Filterable solids and non-filterable solids. So you know what are filterable and non-filterable, right? Filterable means that can be filtered by using filtration technique, and non-filterable means it is not very easy for direct filtration. We have to apply some other technique in order to make the particles bigger so that we can do the filtration. Got it? We have to like do something artificial in order to make the filtration process efficient. Got it? So these are the things you should remember very well about suspended solids. So what are the things which we have discussed until this for suspended solids? Let me start from the beginning. So what are suspended solids? Suspended solids are those particles that are visible to our naked eye that are present in the water we have taken, water sample we have taken. Now, what are the problems regarding suspended solids? Why should we be concerned about suspended solids? There are four different things why we should be concerned about suspended solids. The first thing is psychological effect or aesthetical effect. Right? Because if you people are given a glass of water having suspended solids, you won't drink it, right? Because it is psychologically we can't do it. So that is psychological effect or aesthetic effect. What is the second one? Incrustation. What is incrustation? If you are continuously supplying the suspended solid carrying water through pipeline for a lot of days, what will happen? The pipe will get clogged. Why? Because if you are having a pipe, suspended solid is somewhere it is getting hit means what will happen? It will grow in size and finally it will clog the pipeline. Got it? So the water supply may get disrupted. So incrustation of the pipe is yet another important effect of suspended solids. Now what about the third one? It will act as it will provide a binding area for the disinfection processes or any other treatment processes. Like what we think out of the boxes, if just we are having a suspended solid particle and we are having we are having microbes inside the water. Now, what this microbe will do is it will go and hide behind the suspended solids. Now, when I do chlorination, I know that this particular water sample is having bacteria in it. So, what will I do? I'll try putting chlorine into it, right? I'll put a small calculated amount of chlorine into the water sample. Now, what will happen? This bacteria is hiding behind the suspended solids, and the other side of the suspended solid will provide binding area, active binding area for this chlorine to come and bind. So what happens? This particular chlorine will come. This suspended salt will be providing binding area, so the chlorine will bind them, and the bacteria is here only. So there won't be any interaction between the bacteria and the chlorine. So what happens? The bacteria will not die. So we have to add more and more chlorine. So until all the surfaces are completely binded, we have to apply chlorine, and after that only chlorination effect starts to be. Got it? So I have to apply very large quantity of chlorine in order to purify very small quantity of water. So this will decrease the efficiency of chlorination. Got it? That is one of the most important things. You may be asked in the question, which of the following is the effect of suspended solids? There will be many options, and one of the options will be efficiency of chlorination decrease. You won't even think about this thing. See, chlorination suspended salt, you won't even think about it. Think of a connection about it. But actual answer is that only. Got it? So that you should actually understand the concepts in environmental engineering. That is very important. If you don't know the concept means you won't be able to answer the questions. So because in structural or in GT, you'll be having some formulas, you put the values in it, you'll be getting the answer. But environmental is not like that. You have to have the concept. You have to think and then. Okay, that is why it comes into action. Got it? So that is the third one, right? And we have one more effect. What is the last effect? Yes, if we are having the suspended solids which are organic in nature, what will happen? We know that organic content is getting digested by whom? Bacteria. For microbes, organic content is the food. So if we have some organic content there in water, what will happen? This bacteria will have a tendency to grow in it. So this will increase the growth of microorganisms in the water sample we have taken. So suspended solids will indirectly promote the growth of it will indirectly promote the growth of bacteria or microorganisms. Got it? So these are the main four effects of having suspended solids in water or problems of having suspended solids in water. Now, What are the different sources of suspended solids? What are the different sources? First one is inorganic matter. So inorganic matter means it may be soil, sand, clay, silt, etc. This may come in like water, which may not be good for us to consume, right? Because will you consume water having clay? No, you have to purify it. Again, problem coming. Got it? And the second one is organic matter. Organic matter such as plants, animals, dead animals in our, or insects will be there. Then this planktons will be there, algae will be there. All these things are actually organic matter present in water, right? So what is the problem? Problem of having organic matter in water? One thing, as we told, microbes will grow, right? In order to decay these organic material, we will see that microbes will be growing on it. So excess amount of microbes may happen, and sometimes these microbes will be disease causing, and if we consume the water, this disease will be happening to us. That is one of the problem. Any other problem regarding this organic matter? Will organic matter pose any other problem than this?
Algae will not allow sunlight.
Yes, one of the reasons. We can have eutrophication. Have you heard of eutrophication? That is a very important term you should know when we study environmental. Okay, so it is eutrophication. Now, what is eutrophication? You have a water body. Okay, you are having a water body, and what happens is there is a growth of excessive growth of some algae or some plants or some any sort of an organism there in the water. And what does this organism do? This organism is a dominant organism. So it will be taking up all the sunlight or the oxygen present in the water for its own consumption. So what happens? There will be deficiency of all these things there in the water, right? This process can be classified under eutrophication. So eutrophication happens when in a water body, if you are having an algae cover or a plant cover over it, what happens? Here it was sunlight, right? Sunlight is coming from here, and what happens? All the sunlight is taken up by these particular surface plants only. What happens? There won't be any sunlight that is penetrating into the water. If sunlight comes in, what are the advantages of sunlight coming in? Yes, if sunlight comes in only, the plants present inside this will be able to do photosynthesis. If they do photosynthesis only, they will be releasing oxygen into the water, right? Then only the water will have oxygen. If water has oxygen only, the animals over there will be, the fishes will be able to respire over it, right? So all these things will get hindered by the growth of this plant layer over the water. Got it? So this process is called as eutrophication. Got it. So if you have organic matter in water, the bacteria may use the nutrients, oxygen, and all other resources present in the water for decomposing this organic matter. So what will happen? Other organisms present in the water, such as fishes or the aquatic plants, will not be able to survive. Why? Because they don't get all these things. Got it? So that is another major impact of suspended solids. Got it? Right? Okay. Clear, no? Okay. Now, after that, what is coming up? What was the like last category? It was immiscible liquids. Now, immiscible liquid means those liquid that is unable to dissolve in water, right? If you have oil, grease, and all, that won't dissolve directly in water, right? So, in that case, what will happen? It will stay as a layer over it. So, what is the disadvantage of having that? If I'm having water body like this is my water body, and I'm having oil or grease over it. So what happens? This oil and grease gets accumulated or floats over the surface of water, right? Now what is the problem regarding this? The same problem as that of the eutrophication. Will this oil allow sunlight to pass through it? No, it will capture most of the sunlight and allow only a few amount of light to pass through it, right? So this will not be sufficient for the plants and animals to survive in it. Moreover, if the layer forms over here, it will cut off the contact between air and water, right? So there won't be any active exchange of gases between them. So this will have a higher concentration of carbon dioxide and lower concentration of oxygen. Got it? So this makes a survival of plants and animals inside water in a problem. Got it? So that is another important aspect regarding the immiscible liquids present in water. Got it? So that is another example of suspended solids which we can have. So that is another source of suspended solid. Got it? Got the different sources and effects of the suspended solids now? Clear for you, right? Okay. And then we said about the measurement and limit of suspended solid, right? Measurement is made by using the technique called gravimetric technique, and the limit as per EPA, it is what? Suspended solid should not be greater than 30 mg per liter. So the maximum value should be 30. It should not go exceeding it. Got it? So drinking water standards, it is different. Okay, this is just domestic water standard. Drinking water standard is different. We'll be studying about it later. Got it? So that is about suspended solids. Clear with it now? Just go through the things you have written. Is there any doubt? Means you can ask me. I'll be giving you 2 minutes. Just go through all the things you have written for suspended solids and see if there is any doubt or any anomaly, or if you can add something, means you can add. Okay. So I'll be giving you 2 minutes. Just look into it. Okay, so clear with it? Any doubt? Clear, no? Okay. Now the next physical quantity which we are going to discuss is color of water. Color of water. So what is color? Color is actually like for water. For pure water, what is the case? For pure water, it is colorless. Pure water is colorless. So if you find some characteristic color somewhere there in water, you should conclude that that water is having some other compound than H2. Got it. So what are the different color imparting sources over there? Generally, we have color due to the presence of some dissolved solids. That is the fact. If you have some dissolved solids in water, it will be imparting color. Okay. So what are the different dissolved solids that can impart color? Any idea? You have dye, right? DYE dye. If you have some textile industry nearby you and a water source is nearby there, if you go and observe the water on the water source, you'll be able to see that that particular dye color will be there in the water, right? If that particular industry is doing,
Can be there. So suspended solid also.
it can be there, but that actually has to be categorized as suspended solid because the dominant one is suspended solids. Now we have to remove the suspended solids first, and then we have to get the colored water, and then we do the treatment for colored water. Okay, but we actually know that the color change is actually due to that suspended matter. We know it. But sometimes if you get some colored water, like yellow colored water is there, you have no suspended solids. So you have to you have to estimate that it is due to the presence of dissolved solids. Got it? Now, even though, as he said, if you have a water having suspended solids and you see color in it, you have to identify that the water is not only having suspended solids, it's also having dissolved. Got it? So if you get a water sample, it has suspended solids as well as it has got color means. The meaning is that this particular water has suspended solids plus dissolved solids. Right? Because colors are always imparted by dissolved solids. Got it? Right? Because if you have to get a color uniformly in water means that particular water sample's molecular spaces should be occupied by the samples which we take, right? So that is the reason why we are telling that there should be dissolved solids, only then there will be imparting color. Got it? So we have dissolved solids that is going to impart colors, and different kinds of dissolved solids like dyes can be there, some acids will be there, some alkalis may be there, some salts may be there, some minerals may be there. All those things. Generally, minerals may not be always dissolvable in water, but some are dissolvable. If they dissolve means they can also impart color. Got it? So all these things can cause color in water. Got it? Now, what are the specific impacts of having color in water? Now, why can't we drink a colored water? If I am giving you a pale yellow colored water, will you drink it? If I am giving you a green colored water, even if it looks beautiful, will you drink it? No. Why? You may doubt or suspect for some like composition which is different from that of water, right? That may or may not be good. So, what is the major cause for or impact there is psychological impact. So if you are asked to drink a water having color, a characteristic color means you will not drinking it because of your psychological impact. Got it? Now the next important thing, can I use a colored water for washing your clothes? No. Can I use colored water for a dyeing industry? Colored water coming out, like a red colored water is coming. Can you use it in the dyeing industry? No. Why? Because in the dyeing industry, there you may be using blue color or green color or even red color itself. But you use this colored water means that colored water may have some other dissolved colors in it. So that may cause problem, right? So we cannot use this water for. I cannot use this water for washing or dyeing industry. Washing includes laundry also. Okay, laundry purpose or for dyeing purpose, we won't be able to use this kinds of colored. Got it? Okay, can I go for the third one? The third one is, yes, it is a serious one. If you have some colored water and when it goes for purification, some engineers, what they people, they actually don't know the order to do the like purification. They just think that, okay, anyways, I have to add chlorine. So what they'll do? They'll add the chlorine in the colored water. But the fact is that some colors, okay, some color causing dissolved solids can react with the chlorine to form carcinogenic compounds. So what are carcinogenic compounds? Cancer causing compounds, right? So some colored compounds can react with chlorine to produce carcinogenic compounds. And the fourth one will be some colored compounds. Now you can write the same. Some colored compounds can react with the chlorine. Actually, chlorine in its ionic form should be Cl2. Okay, can react with the chlorine to produce. Instead of carcinogenic, you have to write odor and taste. Some colored compounds can react with the chlorine to produce odor and taste. Clear with it, right? All the four, right? We change 1, 2, 3, 4, 4 different impacts. So what is color? What is the cause of producing color in water? Now what are the 4 different important impacts of having color in water? Got it? Now we can move towards the other technical aspects of color. That is, how are we going to measure color? Okay. So what is the instrument used for measuring color? Okay. Measurement of color. So the instrument used to measure color is called as tintometer. You can write it. Instrument used to measure color is called as tintometer. Inside tintometer, we will be having a small test tube. The entire working we will be studying at last together. Now the technical aspects only I am discussing. Now inside the tintometer, there will be a test tube like structure over there. Okay, and you call it as Nessler's tube. What is it? Nessler's tube. You can note it down. The test tube present inside tintometer is called as Nessler's tube. Got it? Now, what is the reagent used in this? Okay, the reagent used for measurement of color is nothing but platinum. What is it? It will be platinum. But platinum is not used as a raw platinum only. We will be using it in the form of chloroplatinate ion. What is it? Chloroplatinate ion.
What is the meaning of reagent?
Reagent is any chemical that is added to the like test tube or the instrument so that we can get the result very easily. Generally, we add a reagent for different purpose. Sometimes we'll be adding the reagent for enhancing the process. Like sometimes the process will be very feeble that we won't be able to observe. Sometimes if we add the reagent will help to like it will be exhibiting the process a better clearer for us. Sometimes the reagent will be added to make as a mediator. Sometimes both the elements will be very passive elements. See, for example, platinum. Platinum is a very passive element. So we have to make it into an ionic form so that it will be enhancing the reaction. Sometimes the reaction will be very slow. I need the result very speedily, right? So I'll be adding some reagent so that the reaction gets speeder. Sometimes the reaction will be very speedy. I don't want that much speed. Then I'll be adding some reagent so that I can slow down the process. So for different purpose, we'll be adding the reagent. Reagent is actually any intermediate substance that is added to modify the process that is happening inside the reactor. So here inside the instrument, we'll be having tintometer. Inside the tintometer, there will be a test tube that is that is how it is called as the Nessler's tube. And inside the Nessler's tube, we'll be having the reagent that is called as platinum. Okay, and platinum is not used as platinum. We usually have a platinum ornaments. No, it is not used in that form. It is used in the form of chloroplatinate ion. So it is used as an ion means it has having some it is having some significant processes to do inside. We will be studying about the processes later, but the reagent name you should know. It is actually platinum in the form of chloroplatinate ion. So you should be very careful with the question. Sometimes the question will be asked, what is the reagent used in measurement of color? So in the option, you will be either having platinum or having chloroplatinate ion. Both of them won't be given together, but if it is given means you have to go for chloroplatinate ion. Got it? So that is the actual form in which platinum is allocated. Got it? Okay. Now, next thing is you have to know is the principle. What is the principle of this particular technique? The principle of this particular process is color matching technique. What is it? Color matching technique. So how this process is carried out, I'll be showing you video. A video explanation will be given to you, like how is it happening. So I am having videos for it. I'll be showing it to you and explaining it to you, like after studying all the parameters for each of them, like how turbidity is done, how color is measured, how suspended salt is measured. All of these, I'm collecting videos. I'll be showing it all together afterwards. Got it? So that is about measurement of color. Clear with it now? So now we know what is color, how color is imparted into water. So what are the problems of having color in water? Now how can color be measured? The instrument used is tintometer. Tintometer is having a tube inside it which is called Nessler's tube. We'll be using the reagent platinum in the form of chloroplatinate ion. And what is the principle behind the testing? It is color matching technique. Got it? Did someone tell anything? Aditya, did you tell anything? Okay, I got some. Fine. So it is clear for you, right? Any doubts? Okay. So that is about measurement of color. Have I missed anything? Let me see. This I have to discuss. Yes. One more thing I have to discuss, very important one. That is, what is the unit of color? Unit of color. How it is measured in units. Okay. Actually, we are having two different units. The first unit is called as true color unit. What is it? True color unit. We call it as TCU. 1 TCU means 1 true color unit. Got it. Now, another unit is Hazen unit. What is it? Hazen unit. Hazen. Hazen unit. So one true color unit, one TCU or one Hazen unit will be the unit which we use for representing color. Okay. So actually that is measured as the color of platinum. It is measured to a ratio of color of platinum. We'll be studying about it later. So you just note in names. Okay. True color unit or Hazen unit will be the unit of color. Now, all these processes associated with this measurement, that is using the platinum rod, that is the tintometer, is actually done if the color is having a tint of yellow and brown. So, yellowish brown things are measured by using this technique. If some other color comes up, the more advanced technique that we use is spectrometer. What is it? Spectrometer, and the principle is called as spectrophotometric technique. Spectrophotometric technique. So what is spectrophotometric? You can split the term into three and then you'll be understand the meaning. What is spectrum? What is spectrum? Something related to, yes, colors. Colors and like spectrum means it will be different bands of colors, different wavelength will be coming, frequency will be coming in, everything will be coming in spectrum. Now what is photo? Photo means something related to light. So we are using color, we are finding color by using light, and metric means measurement, right? So we are measuring color using, we are measuring color using light, that is called as spectrophotometric technique. And the device uses called as spectrophotometer. Okay, we call it as spectrophotometer. And when you go for your higher studies and all, you'll be encountering with this device. Okay, it is a very good device. It is a very advanced sort of a device which can be used for not only for measuring the color. Okay, it can be used for several other applications. Mainly, we'll be using it for measuring color. That is okay. So this is a more advanced technique. It can be used for colors other than yellowish brown colors. Got it? So that is spectrophotometric technique. Especially in the industries and all, they'll be using this technique. They won't be going for this technique, tintometer and all. Okay, that is because it will be having a, like an industry will be providing a lot of fluids, right? So tintometer won't be that much effective to measure all the colors. Why? Because it is color matching technique. We have to manually match between the colors. So that may not be that much efficient. But spectrophotometric technique is very efficient and very advanced method. That is why we'll be using this in industrial scale. Got it? Clear, no? Now that is about color. It is clear, na? Any doubt? No, right? Now we can go for the next thing, that is we haven't discussed about the limit. Just a minute. We have to study about the limit also. Limit of color. Don't worry, I'll be giving it as a table, then you'll be able to understand it. However, you have to scribble the notes, right? So for that you can learn it. So the limit will be 5 to 15 Hazen units. So the limit of color in water should be in between 5 to 15 Hazen units. TCU same only. One Hazen unit is same as one TCU, equal only. It will be 5 to 15 TCU. We will be using Hazen unit for standard. That's okay. Now that is about color, and after that we'll be moving on with the next parameter, that is taste and odor. Taste and odor. Now, what is the major reason behind taste and odor in water? Can you guess? The major reason behind taste and odor in water. I am asking it in real life. Like when we have an odorous water or a taste, like bad tasting water. What may be the major reason behind it? Other components are present inside it, and the major reason is dissolved gases. What is it? Dissolved gases. Have you heard of methane? What is methane? Methane gas. Yes, CH4. It is a very odorous and very bad tasting gas. Right. So if you have methane dissolved in water, it will result in bad smell as well as bad. And another thing, have you heard of H2S? Hydrogen sulfide. Have you heard of it? What is hydrogen sulfide? What smell does it have? Hydrogen sulfide has the smell of rotten egg. You know how much bad it will be, right? So that is another aspect, H2S. Have you heard of mercaptans? Ethyl mercaptan, methyl mercaptan. Have you heard of it? That is also in chemistry. You will be studying about that. I hope. That is also actually odor causing and taste causing materials. Okay. So the major reason. Okay, it is not the only reason. The major reason behind taste and odor is dissolved gases. And what are the major dissolved gases among them? H2S will be there, methane will be there, and mercaptans will be there. So the presence of H2S or methane or mercaptans, dissolved gases in water, can cause taste as well as odor. Now, how are you going to measure it? You can write taste and odor is measured by a device called osmoscope. What is it? Osmoscope. Got it? And the unit in which it is measured is called as TON. It is not ton, it is TON, and the full form is threshold odor number. Actually, we cannot have measurement for taste, right? It is not having any sense for measuring the taste. Why? Because taste, it depends on persons, right? So we can't have a exact measurement or unit for taste, but instead for odor, we can have it as TON. What's TON? It is threshold odor number. Got it? And what about the limit? The limit as per EPA is that TON should not be greater than 3. The value of TON, threshold odor number, should not be greater than 3. Got it? So what are the things which we have discussed now? After color, it was about odor, taste and odor, right? So taste and odor, it is caused by dissolved gases such as H2S, methane or mercaptans. Now, what is the device used to measure taste and odor? It is called as osmoscope. The unit in which it is measured is called TON, threshold odor number. And what is the limit? Threshold odor number value should not be greater than 3. Got it? Got the limit, right? Okay. Now we'll be moving on to the next parameter, that is called temperature. So what is the major reason behind increase or anomalous increase in temperature in water bodies?
Heat coming from the
Yes, we have hot water or very high temperature water that is released into the water bodies from different factories and industries, right? So if you have a refrigeration industry or a coolant industry, we'll be having water with high temperature getting released into the water. So what will happen to the like life or aquatic life in that particular region?
They will not suffer.
They will not be able to survive, right? Why? Because if temperature goes beyond the threshold value, they will die off. So that is one of the major effect of having increased temperature. Now, any relation between temperature and oxygen present inside the water, you know? Any relation regarding temperature and oxygen dissolved in water, dissolved oxygen? Have you heard of the parameter dissolved oxygen? Now, what is dissolved oxygen? DO. Have you heard of it? DO. You people have done experiments around in your lab, right? Environmental engineering lab. DO. Haven't you done DO? Oh, you are COVID batch. Right. I was also COVID batch when I had this lab, but still I had demonstrations. You haven't had it?
Yeah, we have.
Demonstrations were there, no? So what is DO? I'm not having the experiment video with me now. I'll be showing it to you later how we are measuring DO and all. Actually, DO we have to measure it in situ, in the site itself, right? Why? If you take up this water, you bring it to the laboratory. By the meantime, the oxygen level will drastically vary. Okay, because DO is a very, very sensitive parameter. It will vary with conditions. Okay, so now what we need is the DO of water when it is present in the river. So we have to do it in situ. Otherwise, what we will do? If we are unable to bring all the apparatus to the site, if the site is a very remote site, I have to get the water and get the DO. What will you do? You will go for a process called DO fixation. What is it? DO fixation. You are going to take the DO there in a particular kind of a container. You will be having a specialized container. In that, you will be taking the water and you will be sealing it with a particular cap-like substance. I'll be showing it to you somehow. I'll be taking the video and showing it to you. And then the sealing occurs. Now, what will happen? The oxygen level inside that particular water is sealed inside. Okay, so the water will be taken up to the topmost brim and we'll be sealing it with the cap. So what will happen? No oxygen will escape out of the water. Okay, and now we can take it to the laboratory and then we can have it test whenever it is comfortable for us. And we'll be having a few. We'll be adding a few reagents to it so that oxygen will not escape from water. So that process is entirely called as DO fixation. We do DO fixation there in the site and then we can bring it to the laboratory so that the DO won't change. So actually DO is a very sensitive parameter. It can vary with many different parameters over. Okay, so how will it depend with temperature? What is the relation between DO content or oxygen content in water and temperature? You know it?
The temperature is related to carbon dioxide is.
Yes, carbon dioxide oxygen diffusion from water to air has relation with temperature. So how we analyze this in the aspect of oxygen, if I try to draw a graph having oxygen levels and temperature in the x and y axis, okay. So oxygen level in water is here in the y axis and temperature is there in the x axis. My graph will be like this. What is happening? As temperature value goes on increasing, oxygen value goes on decreasing, right? So temperature is having an inverse relation with DO, oxygen content. So if temperature goes beyond a particular value, what will happen? Dissolved oxygen level gets decreased. So if the dissolved oxygen level decrease, what will happen? The plants and animals present in the water won't be able to get enough oxygen content there, right? So that can affect the growth of aquatic life in water. So that is yet another thing you have to be careful about. So you can note that down. Lower levels of dissolved oxygen. Lower level of dissolved oxygen.
No.
Levels of dissolved oxygen can be due to the drastic increase in the temperature. Now we have some fishes and all. This one. Yes, Aditya, I didn't see your message. Temperature is inversely proportional to DO. Yes. And now, what was I about to tell? Yes, sometimes now we have some aquatic organisms that breed according to temperatures. Like some species, now they'll be breeding when it is summer season. Sometimes they'll be breeding when they are in winter season. So when a factory is there releasing hot water during winter season, will the aquatic species who are breeding during the winter season will be able to breed properly? It will affect their breeding, it will affect their speciation, and it will affect their population. So they can even be extinct in that particular area. Got it? So it can affect the breeding. You can write it. You can write the points. I'll be reading out each of the point and then I'll be explaining it. Okay, you can write. Laws of aquatic species. Laws of aquatic species whose survival and breeding are temperature dependent. Wrote it, and after that you can write. The next point you can write. This figure is important. Okay, an increase in 10 degrees Celsius of temperature, 10 degrees Celsius of temperature can double the biological activity. So what does this mean? If you have increased temperature, biological activity, say for example, excessive growth of some plants, like some algal species may happen. Algal blooms may occur more with increased temperature. So what is algal bloom? Algal bloom is the production of new plants of algae. Okay, so algal blooms may occur frequently due to the increase in temperature. Got it? So you can write below. For example, there may be an increase in algal blooms in the water bodies. Algal blooms in the water bodies. And the next point you can write.
How will it double? Increase in the temperature will reduce the oxygen levels.
No. That will happen, or that will affect the aquatic plants. That is the plants and animals that is living inside the water. Now, what about the algae? Algae or water plants or water weeds, they are living above the water surface, over the water surface. So they will be getting ample amount of sunlight. They can take up. They are having aerial parts in their body, right? And what does this aerial parts do? They will take up oxygen directly from the atmosphere. So they don't actually require the entire oxygen to be taken from the water. They'll be taking whatever it is available, and the rest they'll be taking it from the atmosphere. So oxygen is not getting shortened through them. And what they need is temperature. For algal blooms to occur, they require more temperature. So if a controlled temperature is going, means algal blooms will be going controlled. If the temperature of the water increases, or if the water becomes warmer, what will happen is the algal blooms will have a greater tendency to be produced. Got it? So algal blooms will occur frequently, and the population of algae will start to grow more. That is what we have listed. It may double the biological activity. Like if decomposition is gonna happen, means it will double it. So more amount of decomposition happens, bacteria will be growing more, right? That is what the point we are going to write next. The invasive bacteria or the microbial organisms will be increasing. Why? Because the biological activity is going to get doubled. So double amount of bacteria has to be there, right? So that is what is going to happen. It is not like temperature is going to 100 degrees Celsius. No. If you have a separate temperature, say for example, if you go for looking the like limits, the limit of water temperature should be in between 10 degree and 25 degree. So somebody water going into 30 degree or 37 degree, itself is warmer water, right? So that particular temperature is suitable for the algae to grow more. Okay, it is not about 100 degrees Celsius temperature. No, water is not boiling. It is not that much high temperature. We are speaking about a small rise in the temperature, like it is going up to 50 degrees Celsius. So beyond 50 degrees Celsius means we won't be able to touch the water, right? That much hot it will be. It is not that. The threshold temperature or the limit of the temperature should be between 10 and 25 degrees Celsius. And if the water temperature goes beyond that, that is if the water temperature goes to 37 degrees Celsius or 40 degrees Celsius, then what is happening? That is what we are. Got it? Now the next point you can write. Increase in pathogens. Increase in pathogens, comma, microbes, and invasive species. What is it? Invasive species. What is invasive species? Any species that is coming from outside to live inside this particular habitat is called as invasive species. So if temperature goes a bit more warmer, means there may be some other organisms which need this particular temperature, right? There will be outside world. So they will be coming to grow in this water. So invasive species will be more. Got it? Clear, na? Now the next thing you can write. It increases the concentration of some of the pollutants in water, such as ammonia. See, ammonia actually requires a nominal temperature to go. Nominal temperature to be in it. Now, when the temperature goes a bit more warmer, what happens is the ammonia will have a formation to form more. Like nitrogen content present in the water will have a tendency to form into ammonia. Like nitrogen and hydrogen combines to form what? Ammonia, right? N plus H gives you ammonia, right? N2 plus 3H2 gives 2NH3. This is the actual formula, balance formula, right? So this particular reaction is actually a reversible reaction. It may be forward or reverse. Okay. So the forward reaction is favored by increasing temperature. So when temperature increases, what will happen? The forward reaction is favored, which means all the nitrogen and hydrogen present in the water will combine together to form ammonia. Got it? That is why the presence of ammonia or the amount of ammonia present in the water will increase with the increase in temperature. Got it? Any doubt in all these things which we have discussed today? Which one? See, biological activities require a particular amount of temperature to happen. Now, what our water is having is a temperature that is between 10 to 25 degrees Celsius. So there is a limit in having some biological activities when it lies in between 10 to 25 degrees Celsius. Now, when the water grows warmer, that is the 25 degrees Celsius grows to some 37 degrees Celsius or 50 degrees Celsius. Now, whatever is happening or whatever biological activities that is possible to be happened in a warmer water is also now able to happen in this water, right? See, if a warmer water is produced, say for example, this particular conversion, nitrogen to ammonia conversion, that is a biological activity, right? Because a biological process is happening over there. Now, if this reaction is favored by temperature, it will happen more in this water, right? So earlier, nitrogen plus hydrogen gives blue NH3 was happening in a smaller rate. Now when temperature increase, what happened? It has to happen in a larger rate. Why? Because it is favoring the forward reaction, right? So that is what is happening here also. Now any biological activity that is favored by higher temperature, that will be happening more and more. So that is why we are telling that an estimate of 10 degrees Celsius increase in temperature can have double of the biological activities happening.
And the survival of the aquatic animals and plants are also a biological activity.
Survival of aquatic plants and animals is actually not biological. That is a biotic habitat we are having there. Now, biological activity means decomposition is a biological activity. Why? Because we are having carbon getting decomposed into some other compounds of carbon, right? And we have respiration and digestion of the plant that is living over it, right? So if temperature increases, algal bloom goes increasing in a rapid manner means when though this particular few amount of aquatic organism is depleting, the somewhat how much fractions of plants are blooming apart from that. So that much activity is going on increasing in another side. So this particular 10 degrees increase in temperature will not affect the aquatic organisms that much. If it is 20 or 30 degrees Celsius means these organisms will die off completely. But 10 degrees Celsius increase means these organisms will be affected in their breeding, but not in their survival. Breeding is not happening, but survival may still happen in some of the organisms. So that biological activity is still persisting. Now this nitrogen to ammonia conversion or some other compounds conversion is happening inside. Then algal blooms is going like it is going doubling and tripling. So all these things, if you see in the net,